Well, good afternoon. Welcome to homework problem 9.13. Problem statement is locate the centroid for the given figure. To make it very clear, we are looking for the centroid of the shaded area. So a large rectangle with a smaller rectangle cut out of it. A couple things that I noticed right away is that this is a perfectly symmetrical about a uh, vertical line of symmetry. Make it a color that'll blow our mind, of course. So it is perfectly symmetrical about that vertical line. Because of that, we immediately know that the capital X bar, or the X component of the point of the centroid, is going to be half of the length, right? So I think this length is 20 plus 40 plus 20, which is 80. Half of that is 40. So I'm going to go ahead and write that our capital X bar is 40 millimeters. I know that if you did the homework and you've been using the technique that we've talked about in class, you did a whole table and you did an X bar column and an A times X bar column, and you did all those things, but you should have gotten 40 millimeters. Okay. All right, two shapes. So this is a subtraction problem. There are two shapes. So it's the large rectangle. Let me get a color that I'm comfortable using here. Maybe this blue we haven't used in a while. So two shapes. There's the large rectangle. Oh my, that not good. All right, here's the large. That not much better. Large rectangle shape and the smaller rectangle shape. Area of rectangle is length times width. So the large rectangle, oh, we already did that, right? We said it was 80 across. So 80 millimeters and then 120 millimeters high. 80 times 120, I did this morning, it was 9,600 square millimeters. Looking at the smaller rectangle, also length times width, it measures at 40 millimeters times 60 millimeters, and that is equal to, you guessed it, 240 millimeters squared. All right, setting up the table. Shape 1 is going to be my large rectangle. Shape 2 is my small rectangle. The area for the shape 1 was 9,600 square millimeters. Area of the small triangle was 2,400 millimeters. Now I'm subtracting that out. I have to cut that out of the figure, so I'll go ahead and make that a negative. All right, Y bar. Y bar for the large triangle is halfway up. Right, so the large triangle was 120, halfway up is 60 millimeters. I think in the last video, I did something like this. So I'll do that again here. I'm thinking about including that as kind of like my, whoa, that's not right. Kind of including that as part of my norm. So Y bar is 60 millimeters for shape 1. Okay, now shape 2. Shape 2. Shape 2 is going to be, so the distance to the bottom of the small rectangle, so that's 40, plus half of the small rectangle. That should be 70. And I know someone's going to say, hey, I think I got the proportions out of whack a little bit. Yep, probably not exact. But in my head, I'm pretending that it is. So Y bar for the second figure is 70. All right. Well, so as you guys and gals have figured out, from here it's a multiplication addition problem. So 9,600 times 60 is 576,000 cubic millimeters. The cubic comes from square millimeters times meters. And then negative 168,000 cubic millimeters. Negative because remember we're subtracting this area out, so the area was negative 2,400. Negative times positive is negative. All right. Summation of the area. 9,600 minus 2,400 is 7,200 square meters or millimeters. Summation of A y bars is 576,000 minus 168,000. I am desperately hoping that equals out to be 408,000. I'm not hoping, I did it earlier. I know it's right. And a capital Y bar then is the summation of the AY bars divided by summation of the A's. 408,000 divided by 7,200. I didn't forget. I'm going back to put them in right now. And you get 56.66666. I'm going to round that as 56.67 meters. Let's go pull out to figure out where our point is. So it's got to be on the pink line, right? Because it's, we said that the X bar was on the pink line. 56.67 has to be, so that this would be 70. This would be 60, so a little bit less than that. So the ordered pair that describes the centroid, capital X bar, capital Y bar, would be 40 millimeters and 56.67 millimeters. So that means, if we had this object that was homogeneous, and we turned it flat, and we had to hold it on our finger to balance it, and that's where the balance point would be. Problem 9.13. Hey, thanks for watching. Leave comments in the comment section. Hey, good and bad, provide me some feedback so I can get better and make sure that you guys are getting the product that you need. Have a great day. See you later. Bye-bye.